Okay, question 9. Explain the term between specific heat capacity, so that's increase in temperatures, and specific latent heat, that's changing state. So now turn that into sentences. So specific heat capacity measures the energy required to increase temperature without changing state. And then the other one is changing state without changing temperature. Specific latent heat measures the energy required to change state without a temperature change. Going to the next part, we can see we've got some apparatus. We've got a joule meter, and we can see this is all around specific heat, latent heat. The student measures the initial temperature of the water. The power supply is switched on for 10 minutes and then switched off. Explain how the student should then obtain an accurate reading for the fire. So it's not, again, an accurate reading, so it's not after insulation or anything like that, used in the calculation of the specific heat capacity. So we know C equals Q over M delta T. We're just going to talk about all of the kit here and some possible bits that will improve your learning. So make sure you stir the water fully so that the water's the same temperature throughout. Continue the measure in the temperature after switching off, that is get the maximum temperature, because you've put that energy in there, but that doesn't mean that it's conducted through the water fully. So measure the peak temperature as conduction takes time, and take the temperature eye level to avoid parallax error. So let's get your eye level so that you're not above or below it. So some things there where students will just go off the rails again and start, like I did on the other question, start talking about insulation and stuff like that, and that's not what it's actually about in the reading of these things. This is a lovely 6 marker for near the end of a higher tier. So a container of gas is at room temperature, the gas is heated, the volume of the container stays the same. By considering changes in velocities, explain how the temperature affects the average kinetic energy of particles, so we're pretty happy that's going to go up. And the pressure, we're pretty happy that's going to go up. So we've just got to put all of that together. So the gas particles will move at higher speed. When you get things like this, use your equation booklet at the back to help you put as many equations in as you can. So the gas particles have more kinetic energy because K equals half mv squared, and we've increased V. The gas particles will now have increased momentum. And again, I'll show off delta P equals mv. So the pressure increases at higher temperature. So we've now talked about the average kinetic energy and their velocities and the impact there. So the pressure will increase. And now we're going to talk about, because the gas particles collide with the surface with more force, and the surface area is the same because it tells you that there. The next one then is the pressure equals the force over area. If we wanted to, we could even add in here F equals delta P over T. So pressure equals force over area. The gas particles will also collide more frequently, and therefore pressure goes up. So it's two things. We've got more force and it is more frequent, which is that bit frequently gets missed. No pun intended. There we go.